Hey, hi everyone. I hope everyone is well, enjoying the videos. And specifically, I think for this particular video, we are going to be in continuation of where we left off last. So, this is a video that is focused on coding. If you haven't watched my video on coding, please go back and have a look at the first video, which talked about the list and operations. So this one is basically going to talk about the advanced list operations. So remember, just to recap, right? We did talk about lists that are a type of compound data type where you can use to group values, right? Square brackets are used, and then you can have different types of objects, right? Or usually, like I think for all practical purposes, the object types are usually the same, right? So continuing from that, I'm building on some of the functions operations that we had learned. Right. So just to give a recap of, we had done concatenation. We had seen like list are mutable, list can be appended, right? Length of the list, deletion of an element, so on and so forth, right? So I think building on where we had left off last time, I am going to go into more complex functions or operations from interviews perspective. Generally, I think these will be required to solve questions that are expected in the interviews. Uh, this is also probably now touching some of the aspects of software engineering interview questions. So some of the advanced operations that I'm covering here, right, can very well be used for software engineering preparation as well. It's kind of expected that you would know if you have coded in Python. But just as a refresher, also this might be very useful for you, right? So let's start with, I think, the list advanced list operation. So the first one basically is this insert, right? Is basically used to add elements, and then you can use this to actually insert both at the front of the list or at the back of the list, right, or toward the end of the list, right? So how do you add in the front of a list, right? So let's say we have a list that is consisting of elements that are the collection of programming languages, right? So Python, Swift, C++, Ruby, C, and Java, right? Now you want to insert in the front. Now you said basically use insert, and you use index number, which is 0, and then you specify what is the element that you want to add, right? So 0 and Perl in this case, if you do that using this insert function, then you will see the result is that Perl now becomes the first element instead of Python, right? So you have inserted at the start of the list. Now if you want to add towards the end of the list, so how are you going to do? So again, we had our original list which had these elements, right? Now to add to the end of the list, we also had one other function. If you recall from last lecture video, you can leave it in the comment. But here is another way, where in which you can actually add towards the end. You're using a function that also we had covered in the last lecture, where you are looking at the length of the list, uh, list length, and then you're basically saying add towards the end of the list. So when you use this, basically the output is going to be that Perl is going to be added to the end of the list. Now I'll break it down to help you understand what is it that it is helping you with this function length, right? So length of programming language, right, here will tell you five, uh, because there are five, sorry, six. There are six elements, right? So it will return six. And when you say that insert six dot Perl, the sixth position is where it will enter. So remember, indexing always starts with zero. So zero, one, two, three, four, five, right? The sixth element will automatically become Perl, right? So you print it out, you'll see that I think Perl is added to the end of the list, right? So both the start of the list, end of the list, you can use the insert function with the index to actually insert any element, right? And now coming to the index, right? So index is usually useful to identify where a particular element is in the list. So you want to identify where C++ is, right? So you just look at programming language, uh, right? C++, use the index function, it will return 2. So 0, 1 and 2, that is what it is returning. Now, let's say you had two C++ in your list, right? So here, for example, you have C++ here also, which is the second position, and it's also there in the fourth position. Now, how do you identify this one? Like if you want to just look at C++ after the first occurrence. So you're going to basically say programming language dot index C++ after the third position, right? A question for all of you who are watching this video: what will happen if you use the same this programming language dot index C++2? What is the expected output? Leave it in the comment, or maybe try it out yourself in the Jupyter notebook. uh, this is this is how I think index is useful. Um, it is basically to retrieve an element's position in the list, if I have to put it that way, right? You need to know, for example, where is Ruby, where is Java, right? So that is what it is going to help you with, right? Now, coming to the sort functionality, right? The sort functionality of the list. Uh, Lists can be sorted. In most of the cases, when you are adding elements, or in fact, even your raw data when you're reading, right, directly adding to a list might not be sorted, right? To perform any operations, you might have to sort it before you can actually make any sense of the list, right? So, for example, here you had this programming language list. You could have names of students that are being fed from, let's say, some application, right? Then you're storing those in list. And then you want to basically, let's say, alphabetically retrieve that list, right? So here, what you're doing, you're using sort, and then you print it like it is sorting, alphabetically ascending order here, right? If I use a reverse equal to true option within the sort, it is doing a complete flip. It's doing Swift, Ruby, Python, Java, and etc. C++, right? So it's doing a complete flip, right? So both the cases, sort is basically just organizing your list in a fashion, right? In either an ascending order or a descending order, right? This is also, you can use it on a number list also. I just used, I think, the same alphabetical list example, but it's valid for uh, uh, numbers as well, right? Coming to the next operation, the pop operation. So pop operation, as the name suggests, is basically used to pop out an element from the list, right? So if you don't specify, let's say, a pop option in your list, then what will happen? So you have this list programming language. You do a pop. It is going to pop out the last option. You basically have not specified any index. It's using a last whatever this C++ is there. If you print it, you'll see one C++ is gone, right? Now, if you specify with an index option, we say like, I want to get rid of this particular guy with Python, right? So you specify the index option, and then this is what you will get, right? Pop is very useful, I think, in some cases where, like, you might want to, like, remove certain items from the list after a certain time threshold. For example, there is a loop. What are loops and all that, I think can. But I'm just telling you a practical example. If you were to pop out elements, how are you going to do that from a list? Right, at, let's say, a certain threshold of time, you say that all of these elements from the list need to be uh, popped out, right? So this is how you are going to do it. Now, coming to the count, the very straightforward example, it's going to return the number of times a particular element is present, right? So here, for example, you specify C++, it is giving you a count. Twice it is appearing, so it tells you that this is appearing twice in your list, right? So far, I think all the I would say functions or operations, right, should have made, like, I think, good, probably useful, like, understanding of where those operations can be used, correct? Now, jumping on to some advanced, I would say, tier 2, or, like, advanced concepts, is the use of Lambda, right? Now Lambda, I think you'll see, uh, if you know what are user defined functions from any of the programming courses you have learned or taken in the past. uh, if you have not, let me explain what a user defined function is. User defined functions are basically functions that are to be repeatedly, let's say, used inside your program. uh, I don't want to basically type in the, let's say, the same function again and again and again, right? uh, the function is a set of operation that you want to do, right? That is what it meant by function. It's a set of operation. So user defined functions, for example, if I'm looking at user defined functions, what it means is, obviously you have to give it a name. It can contain very complex expression and can be executed any number of times, right? So straightforward example, I defined a function called function square, right? Now in this function square, I am saying that I will take x as an argument, right? And I will store that square of that function, square of that number, whatever your parse is x, and then I'm going to print it, right? That is what this function is doing. Y is equal to x square of 2 means, sorry, y x of uh, times 2 means that you are returning a square, and then you are printing a y, right? So now I call this function, right, in the next line. Function square 3 is basically going to return the square of 3, right? So it's doing 3 into 3 essentially, right? And it's printing out the outcome y, correct? Now I am introducing another, let's say, category of functions within Python. It's called Lambda, right? They usually go by the name of anonymous functions because they don't have any name. Like here, you put in a name, function underscore square. You called also that function, right? Lambdas don't have any names, right? I would also say that lambdas have some limitation. You can have simple expressions, uh, when you're using lambda functions. In most cases, I think you'll see lambda being used only once, or probably finite number of times, if I have to be like, putting it more precisely, right? Whereas here you had seen like any number of times I can use the user-defined functions, correct? And the expression can also be complex and it had a name, right? Lambdas do not have a name, right? So now translating our same, let's say, um, example, right, where we had the function square, we defined it. How do you do it with lambda? So with lambda, you just say lambda x, and then the same expression, that is like the square function, right? X star star 2, right? It will return that, okay, it is understood that this is a function main, right, a lambda. And then how do you call this function? Like, how do you get the output, right? So you basically treat it as a function the way you had like this. But remember, because this function doesn't have a name, right? So because lambda doesn't have a name, you can't specify basically this part, which is the function underscore square, right? You still have to go with the brackets. So you say inside the brackets, basically what you're doing is you're passing the argument itself, right? There's no function name, and that's why it's called an anonymous function, right? So lambda x, basically, you're saying, I want to use this function, right? This is an invocation of the function, and you're saying I want 3. I want the square of 3. So basically, this is what you get. You can define any sort of function, but the way lambda functions will always be without a name, right? Now, I'm going to bring in a more interesting case of our sort example. So remember, we had done the sort, right? We had done the sort where we said, okay, do a sort with the to go option, right? Now, what if I want to use a lambda function, which might sound very counterintuitive because sort itself is giving you the functionality. But the idea here is to actually help you understand that lambda here is being used to define a sort functionality, right? So here, for example, we had our whatever programming language, right? I'm saying that I want to sort where the key is lambda x equal to x, right? So I haven't obviously given any reverse option here, right? But if I were to give it, I can give it inside the sort function. But here I'm saying that key is equal to lambda, which is a lambda function, right? And basically every element should be sorted. X double dots x basically means that every element should be sorted, right? So now, for example, what I'm going to do is, um, I am going to print the outcome, right? So you'll see that the outcome is C, C++, Java, Ruby, Swift. Now, I think if this programming language was not sorted right, you had Ruby in the first, C++, and then Java in let's say unsorted order. If you'd used this, then you would have gotten the sorted programming language outcome, right? So where is the lambda function coming into picture? It's obviously making life more complex for sure, because sort is already a function here. Remember, I think uh, the idea of using lambda is for its simplicity, right? So here, for example, this one makes sense because I just have to type one line of code and I use it and I get it. I don't have to go and define a function, then do a print, and then call the function, right? So there are multiple steps. With lambda, it's straightforward. Define the function, pass the argument, you get the output, right? Sort, because it is already uh, a defined function, right, within Python. You're not seeing its benefits as such, and which is where it is making it slightly more complicated, wherein you are sorting, every element X in the list, right? But remember that lambda can also be used. The other area that I wanted to highlight is you can use lambda inside an already defined function within Python, right? So Python, for example, sort is our function here, right? It's a language defined, like, function that is there. So you're using lambda inside that, right? That is what I wanted to actually highlight here, right? So you'll see more complex use cases of it. Let's say if you have tuples, for example, right? And I'll touch this in string stacks and queues and tuples when we cover tuples, right? I'm definitely going to cover this where you will see its true power, of lambda as a function. Because tuples will have multiple lists within a list, right? That is what tuples is. So we'll touch upon it, but just keep in mind that lambda as a function can also be used within a function, right? Of already defined user function, right? Sorry, language defined function, right? Now, also touching upon some topics wherein lists can be used as queues or lists can be used as stacks. So lists can be used as queues wherein the last element added is the first to be retrieved, right? It acts as a LIFO. You can use append and pop, uh, right? You had the append and the pop function. I would say lists are not efficient if inserts and pops are from the beginning of the list, right? Uh, from the end of the list, yes, definitely more efficient. But lists are not, I would say, if inserts and pops are happening from the beginning of the list. Specifically, if you plan to use list as queues, right? Lists can also be used as stacks. Last element added, again, first to be retrieved, use of append and pop. We'll definitely go into more details of stacks, strings, queues in our next video. But I just wanted to give you an idea of the list can also be used as queues and list can also be used as stacks. I'm not covering any examples because I think queues and stacks themselves will have more capabilities if, as opposed to when you're trying to use lists as queues and stacks, right? So watch out for my next video, right? We've covered fairly around like 11, 12 operations for now. I think if you look at lists, right, they should be more than sufficient, I think, for your interviews. When we jump into, I think, interview questions, you will see all of it coming together. But for now, I think go back and have a look at, maybe some sample questions. Leave it in comments if you have any doubts, any, concept that you were not able to understand. In the next videos, we are going to cover string stacks and queues. So hope this video was useful, and if you've not liked or subscribed, please do that. and I'll post the next video very soon. Thanks.